Well, good evening. Welcome to Space Oddities. We're back for 2024, and we like to wish you, obviously, a Happy New Year. We hope that your Christmases and respective New Years went fantastically, and that you're raring to go for the New Year, as are we. So, what's been happening? Well, let's see who we've got, first of all. We've got Roger tonight. Hi, Roger. Happy New Year.
Good evening.
We've got Daz in his polar bear pimp outfit, I think.
Polar bear one. This is me NASA one.
Oh, it's your NASA one. I'm so sorry. Right, okay.
Yeah. New Year, everybody. Hope everybody had a good festive season. Now let's look forward to 2024 and lots of rockets this season.
Yeah, absolutely. Looks like it's going to be a fantastic year in space again. But we'll talk more about that later. Michael, how are you?
Hi there. Very well, thank you.
Right,
Good
okay.
to be back after the break.
Yeah, jolly good. And the lovely Rachel, who had the equally wonderful Isaac with her earlier, but he appears to have crawled off somewhere. So how are you, Rachel? You okay?
Yes, I'm good, thank you.
Isaac's setting off.
It has rained for what feels
yeah,
like.
we got floods here.
Tell me about it.
We got floods.
I was on the coast of Pembrokeshire, and you'll never guess what happened in Pembrokeshire. It was constant wind and rain for 6 days.
We literally had a tornado warning the other day, and I was
no way.
It's a joke. And there genuinely was a tornado not far away, apparently.
Yeah, that's right. Yeah.
I mean, we've basically had 3 weeks of named storms.
Yeah.
So
I was calling them names, I can tell you.
Yeah.
The observatory roof stayed on.
Did it mess your hair up, Andy?
I blew my wig off. I haven't got a new one yet.
Wiggy.
So there we are. Anyway, if this is your first time watching Space Oddities, you are very welcome indeed. Thank you for joining us. Thank you for becoming part of our community. If you haven't yet subscribed, hit the subscribe bell, hit the like button, hit the notification icon, all of which will enable you to find out when we're doing things and keep you in touch with us, because we are here to deliver the universe to you. And we will continue this year to endeavour to cover everything that's going on in space. Well, as much as we can. We cannot cover everything because it's all getting a bit out of control, really. There's so much news every week now and things going on. But we'll do our very best to bring you certainly the major stories from astronomy, from cosmology, astrophysics, space exploration. You know how it goes if you've been here before. And to our regular viewers, thank you for coming back. That's basically it. Thank you for being here as well, obviously. We do appreciate it. All right, what have we got coming up today? Well, we thought we would do a review of some of those news stories from 2023. Obviously, as I just said, there's so much news. We're not going to cover every single news story from the last year. But Daz and I have picked out some that we thought were interesting one way or another. So we'll be doing that a little later. Before we do that, though, can I just say thank you to those of you who continue to buy us coffees, and much appreciated. And your money that you buy us coffees with goes towards helping the channel survive and keep going and developing. And we thank you for that. It's very, very kind of you to spend your money on us. We do appreciate it. It enables us to do what we do and do it better. So there we are. And don't forget that the Space Oddities merchandise is still on sale. The T-shirts and hoodies, unfortunately, because our supplier has raised their prices, we're going to have to introduce a slight price rise very soon. We're discussing it at the moment. So now is the best time to buy before the prices go up. You'll find the link to buy your T-shirts and hoodies in the description of this video, and we'll pop the code up for you to scan if you would like to do so a little later as well.
I think Chris is asking questions in the house because it's a scandal. He said, "Don't you buy coffee with it?" We did have biscuits once.
Yeah. Well, the thing is, we get so much money that people give us in coffee. We couldn't possibly spend it all on coffee, Chris.
Alcohol.
We spend a little of it on coffee. So there we are. And anyway, let's move on with the show. We're going to do so in the time-honoured tradition of going to the man with his thumb on the print of the, I don't know, something. This is Roger, anyway. How's it going, Roger? What we've got to look forward to in the night sky?
Well, we do have a few items on the itinerary for the coming week, so I will press ahead. Okay, so first week of January, here we go. At the moment, we're just coming out to the last quarter to onwards for another week before we get the new moon. This was taken in the wee hours of January the 1st, so I managed to get a lunar image almost immediately for 2024, which is rather miraculous with all the weather that we've been having. But it's not looking too bad outside at the moment, actually, so I might pop out again for another wee photograph or two. But at the moment, these are what we can expect to see in the night sky, looking south at 11 o'clock at night. And as we can see, Orion is dominating the southern horizon. And we've got the full winter circle all on view.
Yeah.
And Jupiter over in the southwest now, with Saturn setting earlier in the evening, unfortunately. But things are still looking rather nice, especially when we've got all those objects that we all learn and love to see in the constellation of Orion. And as I gradually scroll across, we will get to the wee early hours of the morning before sunrise. And we've got Venus shining very nicely up in the horizon, and not too long after, we've got Mercury. And during later on in the week, it will be at its highest point at sunrise, which will be roughly about 11 hours in the night sky. But just before sunrise, we've also got Mars. But obviously, with it being so close to the sun in the sky, it's obviously too faint to see, because it's not exactly at its optimum distance for observation. This just giving you an indication. If you want to see Mercury, this is the latitude at sunrise where it will be. So over the next few days, it will be at its best to see, and it will be roughly 50%. Although it does change quite a lot, like the moon, each night. So it's interesting to see the phases even over just a week that you can see, should you have a clear enough horizon to be able to spot it. It's one of those planets that you don't get to see very often at all. And currently through this week, we've got the Quantridids meteors that will be... and according to my information, you get a zenithal hourly rate of about 110, although that could be taken with a pinch of salt.
It's still a lot, though, isn't it?
I think it's still quite a lot, yes, but I don't think they're too bright as we've had with some of the other regular, well-known meteor showers. But there is a possibility. So this will be at roughly midnight, roughly just northeast. Obviously, it will rise slightly higher through the night. So be on the lookout if you do spot.
I saw a beautiful bright one just skimming the eastern edge of Orion last night. Absolutely stunning. So I guess that was sporadic.
Yeah. And this is a follow-on from Comet 62P Schuschnigg. It's coming out from the tail of Orion and heading on towards the galactic numeracy that is the constellation of Virgo. Yes. So more photo bombing.
Sorry, what's the name of that comet again? I think you sneezed.
Yeah, Schuschnigg. Yes. Yeah. It's staying fairly constant at roughly about an 8.3. So a pair of binoculars or a small telescope will be able to pick it out.
Yeah.
And here it is, photo bombing the Leo triplet.
Oh, lovely.
Not my image. I have got the Kremet, Roland. And this is taken from Namibia. So obviously got a Bortle 1 sky to get the clarity of everything that you see.
Beautiful.
Yeah. it was even closer than I thought it was going to be to
Yeah.
the Leo triplet.
Well,
So
obviously, it's probably their
it's going to
latitude,
be
wasn't it?
heading. Yeah, it'll be going through Mercurian's chain in about another
that's
month.
another one.
So
Oh yeah.
that'll be another one. So if I go back there, you can obviously see it going through them there in that position. So another opportunity, right? But if you want to have a look for another comet, this one's in Cygnus, although you'll have to start to lose Cygnus because it's setting down over in the west. But it will be visible again in April, when it will be almost at its closest point to the Earth. That is comet 12P Pons-Brooks. So another photo opportunity for a comet to go through Cygnus with a few interesting objects there as well. So we sort of like the buses, where we get quite a few of them as well to come through, and slightly brighter this one by about a quarter of a magnitude, but still an opportunity to capture something else if you like these wandering stars. And it's quite an interesting shape at the moment, Pons-Brooks. It's sort of got called the Millennium Falcon comet, or the sort of the horned comet, because of the outflashing of material from the comet itself. So should be quite interesting, and forecasting maybe magnitude 4 or so by about April.
Oh, that's quite bright.
Yeah, I mean it did brighten up quite considerably, which gives the impression of the shape that is at the moment. So whether it'll survive further on in, we'll have to see.
Of course, if it's circular, that's probably going to mean a higher surface brightness. So.
Look at that.
And
wow.
There we are. This is just some interesting comparisons between the Webb and the objects that it's managed to gravitational lens of a nova. So it's repeating the same image in various locations around this gravitational lens.
So that's the Hubble, and is that the Webb?
Yeah,
is it? Yeah,
the Hubble in 2016 and the Webb on the right.
Yeah.
Wow.
So
but look at the difference in resolution.
Yeah.
It's amazing.
Absolutely amazing. Yeah.
Amazing.
So roughly 10 billion light years away. And it was only taken in the 5th of December, so it's not a month old, that image. So that's quite interesting. And
okay,
thank you
very much, Roger. That's absolutely brilliant.
Okay.
Right, jolly good. Yes, we'll be talking about some of the Webb images from 2023 a little later this evening. But right now, we're going to go straight from Roger's Night Sky Guide over to another of our regular features, which is Rachel's Viewers Gallery. So thank you to all our viewers who've sent in images for the gallery. Cue the Vision On music, and let's cue Rachel. So, Rachel, what have you got for us?
We have some really nice images in today, actually.
Yeah, I can't see your presentation.
Has it not popped up again?
No.
Did this last time. Try it now.
Hang on 1 second. Get to the bottom. There we are. That's good.
Hey, there we go. Okay, so some really, really nice images as usual of a high standard from our viewers, and keeping the
that's because I didn't put any in.
You always lower the tone.
Keeping with the festive spirit still, even though we're in January, we've got the Christmas tree and cone nebula by Jerry.
Well done, Jerry.
Beautiful.
Which,
look at that. That's really spectacular, isn't it?
Isn't that wonderful?
But very, very nice, Jerry.
Well done, Jerry. Another winner.
Then we've got Sonia's sent in. She's been having lots of fun using her sea star. So she's taken a picture of the moon. And
lovely,
she's also
Sonia.
sent in. She captured the Luna X and the Luna V.
I can see. Yeah.
There you go.
The V at the top. Yeah.
Absolutely.
Excellent. Well done.
Yeah.
Very good. Then I asked Chris to send in some things and keep it obscure, and he always delivers. So he's done the Flying Dragon Nebula in
Oh, wow.
14 hours worth.
What? That's dedication, Chris.
Which,
and it does look like a flying dragon,
That
doesn't
is stunning. Yeah.
yeah.
Yes.
I can see that.
The bottom one looks like a leaping frog.
Where are you?
What?
What are you?
The
What are you
bottom
thinking?
bit below the dragon.
A
Yeah.
leaping.
Or is that a Tyrannosaurus Rex head?
What are you looking at?
Oh, I see. Yes, I see the T-Rex
Well,
head. Yes. Yes.
I'm gonna have to come back and look at this later. But it's very, very nice. So well done, Chris.
Well done, Chris. That is lovely.
That's
Lovely
gorgeous.
image.
And I think we've got a trio from Chris. So this one's the Clamshell Nebula, and he said it's a large complex of emission nebula in the constellation of Cygnus, and the bright star in the centre is 68 Cygni, a fifth magnitude star responsible for ionizing the surrounding gas.
And
And he
is
said there's
8
also
now.
some Bock globules in there. So
The real JWST feel about it, of is it the Carina Nebula? Which one did they do?
Yeah. Yeah.
We'll
And
have
this is
to,
18 hours integration.
you're going to have to magnify
Oh,
on
dear.
that when he said there's some Bock globules, which is a star encased in pushing away its gas, so it forms this sort of like cocoon, and you can see them like bubbles. So we'll have to have a look at that later.
Definitely.
Beautiful.
Mm.
And then I think this is our last one again by Chris. And he said this one is normally, I think, captured as the dolphin, but he pulled out enough O3 to get the integration into the whole circle that you can see here.
Lovely.
Which
Oh, wow.
it's really nice because you don't have, well, I don't see these targets very often, so done so well. And to finish and say thank you, we've just got a few highlights of everything that has been sent in over last year. So we did a little artistic slice of everybody together. Look, and
yeah.
you'll
So
see
yes,
a few of our regulars in there. We've got some shots from Lee, some I think some planets and suns from Kev. I think that must be Roger's Jupiter. I want to say, Rog.
Probably.
So, we had a real high standard, but I think we can beat it this year.
So
if we get the clear
gauntlet has been
skies.
thrown down, so let's see if we can keep it rolling into.
Yeah. So from all of us at Space Oddities, thank you so much for sending your images in to us. And well, I think you know by now how much we do absolutely adore looking at them each week. So let's see some even more incredible ones this year in 2024. So we look
Mentioned the sun there. Sorry, we mentioned the sun there earlier. We were talking that on the literally on the tail end of 2023, there was a big flare on the sun, which is an X5 flare. I have got a video of it. If we got time, I might put it up later. But that hit us this afternoon. So unfortunately, we won't get any sort of like half decent auroras. But it hit us this afternoon. But it just goes to show that the sun hasn't finished yet. I'm just waiting for the final count of sunspots for last month to see if we're still climbing again, because it did drop down for a while. See if we're going to have a double peak. There's no guarantee we will, but the sun's still firing some stuff off us. And if we got time later on, then what I'll do is I'll pop it up and we can have a look at it again, because you could even see, I was pointing out to the chaps here that you can actually see the shockwave move away around the sun. And this is why, even though it was off to our east, literally it was on the limb of it was at 9 o'clock on the limb of the actual sun, because of that shockwave, that's why we got such a big hammering. Really, we were thumped quite big. So it was really interesting. It was really interesting. But look out for some more.
Starry Downer said he wants to recommend NGC 2024 for this year's imaging.
Which one?
NGC 2024, which is the flame.
Yes, indeed. That's a good one.
See what you did there.
Very good. Very good. Very good indeed. All right. So anyway, So we'll move on to look back, not in anger, but with a sense of amazement at the events in space in the last year. 2023 was an incredible year in space, not just for astronomy, but for astrophysics, for cosmology, for the exploration of space. It was an amazing year with so much going on that we did our best to cover here on Space Oddities. So we had a busy year, and we want to reflect that by looking back at some of the major news stories that Daz and I have just selected, not at random, but just interesting stories about things that were going on in 2023. So let's start off. Daz, I'll lead if you like. And
yeah, no problem, mate. No problem.
Okay, just give me 1 second to get there. Okay, so 2023 came and went, but it was a long year in terms of space with a lot going on. So let's have a look at my first story that I've selected. If one country can claim to have had major and quite unexpected successes in space, it was India, of course. Now, what India mounted, of course, was the landing of their Chandrayaan-3 spacecraft. India became the first country to land ever at the lunar South Pole, first country to land at the South Pole of the moon, which was an incredible triumph for Indian science and technology, and is doing wonders for science education and careers in India, as you can imagine. India landed basically 2 vehicles on the moon. The lander was called Vikram, and that disgorged a little rover called Pragyan with several experiments on board. And the scientific objectives of those craft were, number 1, to demonstrate a safe and soft landing on the lunar surface, which was accomplished. Number 2, to demonstrate roving on the moon, which again was accomplished successfully. And number 3, to conduct in situ scientific experiments on the surface of the moon, which the Chandrayaan spacecraft did magnificently. So just a few images from that. There's an image taken from the orbiter of Chandrayaan on the moon. You can see it very clearly there with its long shadow. It's got a long shadow, of course, because it was approaching. The whole mission only lasted 2 weeks because it got there at lunar sunrise and basically died during the long lunar night. Unfortunately, India were hopeful that the spacecraft was going to survive the lunar night, but unfortunately neither the lander nor the rover actually did. But never mind, they completed all of the mission objectives, so surviving the long lunar night would have been an added bonus, but it wasn't to be, unfortunately. Here's a lovely little video of the rover being put down on the surface from the spacecraft, from Vikram. And there it goes. It trundles off, and you'll notice it gets very, very close to a crater not far from the landing site. And it stopped itself because it realized, and it backed up and went round the crater. So that's that. And here's a lovely image that the rover took of the Vikram lander. The colors look a bit mad because this is actually a 3D image, as you can probably make out. But anyway, that's the spacecraft actually taken from the rover itself. The results from this, what did India spend all this money on? What did they get out of it? Well, first of all, there were several results. First of all, there was the first detection of sulfur on the lunar surface, presumably from past volcanic activity in the distant past billions of years ago. And this will help scientists understand the moon's geology and formation a little more. One of the experiments measured the near-surface plasma content, which is very, very useful for understanding the moon's plasma environment, especially for future human explorations. They reckoned that about 2 tons, just over 2 tons of lunar regolith, or the epiregolith, as they now call it, the stuff right at the top of the lunar regolith, the powdery stuff right on the surface. 2 tons of that was ejected and covered an area of 108 square meters around the landing site. There were detections of some elements just laying on top of the soil: aluminium, calcium, iron, chromium, titanium, manganese, silicon, and oxygen. And you can see why people are getting quite interested in the idea of going mining on the moon, because these minerals are just laying around waiting for collection. They did really want to find hydrogen on the moon, but unfortunately the experiments designed to detect hydrogen did not detect any. And also the Chaste payload made first observations of the moon's X-ray and gamma ray emissions. This tells us a lot about the moon's surface and what's immediately under the surface. Also in 2023, India launched Aditya L1, a spacecraft to study the sun, and a very successful launch again in September from India. And there we are. So Daz, that's my first one. What about you? What have you
Right.
got?
Okay then.
Let me just get rid of this.
Well, just a quick word, because one of the things that the Indian lander did do as well, it actually did a hop.
Oh, that's true. It did, yes.
It did a hop and it moved just a couple of meters and then it landed again.
Yeah.
And this is all, of course, because by the end of this year, the Indian Space Agency hopes to be returning to the moon with Chandra. Is it 3 or 4? I can't remember now. And they
It's 6, I think it is.
Oh, 6 is it? Well,
Yeah.
yeah. And what they'll be doing is they want to so the hop was to show that they could leave the surface again because they want to do a sample return.
Yes.
And the actual excuse me, the actual vehicle that took the lander to the moon and dropped it off. Now, this wasn't mentioned at the time, but they've actually returned it to Earth, and it's in Earth orbit.
That's right.
Again, part of the proof of concept that they could actually bring
stuff back on the moon. Yeah.
back, so they could do it, and they did do it. And I think that came back in end of last year, somewhere, or
yes, it was
like that.
mid December, wasn't it? I think.
Yeah, and it came back in, and it went into orbit. So that they're zooming ahead, and with China, Japan, and all the other up and coming countries, India. The space race is well and truly on.
Absolutely.
Again, but with more contestants this time.
And we know that China's got big plans for the moon. So
exactly, yeah.
So there we are. Right then. So what's your first story?
Right. Then? Okay then. Let me just bring mine up. Oh no, that's the wrong one. It went to the wrong one then. Right. The first one is the Lucy flyby of Dinkinesh.
Ah, yes.
Now this is only a short one. Now I found this absolutely fascinating. Dinkinesh, before Lucy actually was launched, well, even after, didn't have a name. It just had a dedication number to it, a designation number to it. Now Lucy, as we all know, is on its way to Jupiter, and it's going to be examining what we call the Trojan asteroids that that sit in the orbit of Jupiter. And the Trojans, there's 2 lots of asteroids. One's called the Greek camp, one's called the Trojan camp, and they sit at the Lagrange points before and after in this orbit. And Lucy's going to be visiting both camps of asteroids and investigating them. And they call it looking at the fossils of the universe, because the asteroids are believed to have formed when not the universe, the solar system, sorry, the fossils of the solar formed at the same time. So, and of course, Lucy was the name given to it for the simple reason that because it's looking at fossils, the oldest fossil we have of a humanid was a female Australopithecus type human, and they called her Lucy. And the reason she was called Lucy, because at the time in the hits was Lucy in the Sky with Diamonds by the Beatles. So they named her Lucy, Lucy, because it's going to be looking at the fossils. Now, it's a 12-year mission, and the reason it's so long is that it's doing lots of loops. It's getting, instead of having engines to push it through space, it's doing gravitational assists around the Earth several times before it'll finally reach Jupiter. But on its way, it was passing this asteroid, so they said, oh, okay, then we'll test out our remote tracking camera. But we want to give this asteroid a name, so they gave it Dinkinesh, which is in the I think it's Aramesh language actually means you are wonderful. So that's why they called it, which is also the name in Aramesh of the actual same fossil, Lucy fossil. That's what they call it. So they gave it that name. Well, of course, we were all excited, and I'll just advance a thing. Must stop using my cursor because nobody can see it. So okay then. So the first surprise is Dinkinesh had a baby Dinkinesh. And nobody knew that this was actually a binary system. So it was a big surprise to everyone because we couldn't see it as Lucy approached. But as it eventually got closer, slowly baby Dinkinesh appeared behind it. So this is a little moonlet or asteroid or whatever you want to call it, which is actually orbiting the bigger object. So that was the first surprise. But as Lucy moved away and came from a different perspective, because again, as I said, it was just passing by and it was tracking with the camera. You can see baby Dinkinesh is twin.
This was an amazing surprise.
Yeah. And it's a contact binary.
Yeah.
So it's actually got two. We don't know whether it's one object that's split apart and then joined back together again, or it's two small objects that have come together and are actually in contact with each other. But they decided to call this Selam, so which is Selam. And again, that's aromatic, Aramesh language again. And this again is along the fossil line because it's the name that was given to a 3-year-old
Astropithecus.
Child that was found, the fossils of a 3-year-old child. So they kept it, the theme running. So it's actually got a name now. It's actually called Salaman, and it's a Amharic language. Sorry, but it's a lot smaller than, as you can see, than the larger object. But that was a big surprise to everyone. And I thought that was really fantastic. And of course, I did put the date on the front, and I think this all happened in November, at the very beginning of November. And of course, we were there and we sort of like watched it. But of course, when we were watching it, with the data come through, it's sort of like, because it was taking time for the data to come through and the moving path, they cut off the sequence. And of course, the actual discovery of the twins of the other twin wasn't discovered until they developed they processed the data later, and then from the later images, and that's when it all came out. I thought that was just an absolutely fantastic night when we watched that. And then later on, like I say, the next day when they brought the other images out and we saw it was two satellites in a contact binary, I thought that was fantastic. So that was just a quick one, but I think that was one of my highlights.
No, it was one of mine as well. I mean, firstly, finding that Dinkinesh had a moon, and then finding the moon was actually twins, was the universe does throw these curveballs at us quite regularly, and that was a real one. Michael, what did you make of that? Did you find that interesting as well?
You're muted.
You're on mute.
Absolutely amazing, really. To even find Dinkinesh as anyway, and then having a twin, it's just incredible. And
it is.
We just don't know, do we, how small these objects are until we actually get there. You know.
Yeah. I mean, if you remember New Horizons' encounter with Arakoth.
Yeah,
another contact, probably the most famous contact binary thus far, where you could see the weld line, if you like, and you could see very easily how these two bodies have come together, and very slowly, because it happens very slowly at a relative speed of probably only about a mile an hour or something.
Yeah. Yeah.
But that speed is sufficient to push them together and sort of weld them together.
Yeah.
And now we've got another example to study.
Yeah, exactly.
So,
and of course, it's the next object it's going to pass is Donald Johanson, which again is another. Which again is another asteroid which didn't have a name until this mission started. And of course, Donald Johanson was the person who discovered Lucy.
Okay.
Exactly. Can you remember off the top of your head when that's happening, Daz? The Donald Johanson?
I can't tell you offhand.
Oh, don't worry. But rest assured, viewers, we will cover it for you. We'll be there to give you all the information.
Andy, just one other comment on the size of these asteroids that we're finding.
Yeah.
How small can an asteroid be before it becomes dust?
That's
well, it has to go through rock, stone, grit, then sand.
Pebbles. Don't forget pebbles.
Oh, pebbles.
Pebbles. Yes.
Yeah. All right, then. Let's move on. So my next one, another country which can lay claim to having had a triumphant year in space is, of course, China.
Of course.
And China has had an amazing year in space. And it's broken a few of its own records this year. It's launched over 200 spacecraft this year in 60 missions. And the Long March rocket, which is the workhorse of the Chinese space industry, much like the Falcon 9 is SpaceX's workhorse, the Long March has got a 100% reliability record. It's never failed. And it's now been launched more than 500 times. SpaceX with the Falcon 9 have got a 98% success rate. And so, this Long March rocket is amazing. And Michael, the Long March is quite venerable now, isn't it? It's been going for years.
Oh, God. I mean, I can't remember how far back it goes.
No, it goes back a long way. But they've announced plans. I don't know whether you knew this, Michael, but in 2023, China has announced plans for a reusable variant of Long March, which will be the Long March 9. And they're aiming for at least first stage reusability by 2030.
Wow, that's good.
But it gets better because there's also the Long March 10, which is the rocket that will take the Chinese Tigernauts to the moon. And it had its first successful engine test in 2023 and should be operational by 2027.
Right.
So China are on their way to putting people on the moon.
So I wonder who will be there first then.
Exactly. They've also announced this year that they're spending a lot of money developing space-based microwave power from the sun. So this is free solar power. Of course, the sun's energy is free, which will be collected by massive solar panels and beamed to Earth in the form of microwave beams and laser beams. And this satellite is going to weigh 1,000 tons, believe it or not, which is going to be amazing. But they want to build one in lunar orbit to supply their future moon bases with electricity directly from the sun. And that one is planned to be 10,000 tons in weight and supplying 1 billion watts of power, if you can imagine that.
Oh,
I know. That is, it sounds impossible, but then, I would think if any nation can do it, is the Chinese, because they have the dedication and the money to do it. So that will be interesting for the future. But China is probably the first country to be putting serious money into the idea of beaming down energy collected from the sun by solar panels in the form of microwaves and laser beams straight to the Earth. If we could do that over the Earth, if every country could do that, we would have all of our energy problems solved forever. Well, at least for the next billion years, at least.
A Dyson sphere.
Yeah. So, exactly. So
it's just a shame that China is not very forthcoming in the, producing information from these missions.
No, that's right. That's right. However, if they want to be serious players on the world stage, I think they're going to have to change their mindset a bit and cooperate a little more and be a bit more forthcoming about what they're doing instead of being so secretive.
Yeah.
Also, they completed the Tiangong space station this year.
Yeah.
And there's a photograph of the completely assembled station. It looks impressive, but you've got to remember this is a lot smaller than the International Space Station. And there's a comparison. The International Space Station is 357 feet long, or 109 meters, but Tiangong is only 114, or 35 meters. And the pressurized internal volume is only 115 cubic meters, as opposed to 900 cubic meters for the International Space Station. So it's a lot smaller. Having said that, have you seen the photographs of the interior? It's
isn't it a much tidier place?
It's a much tidier environment. They really need to get a gang of a company of cleaners up to the ISS to tidy it up a bit, because it's a mess.
Yeah. Was it how clean is your house? Something like that.
Yeah, something like that. That's right. How clean is your space station?
Yeah.
But for the moment, construction is finished. They have got plans to put a multi-docking port module onto it at some point in the future. But for the moment, construction of the space station is complete, and they've done that. Well, it's just over a year, isn't it, since I think they started building it. So it hasn't taken them long to get a complete, functional, and more or less permanently fully crewed space station into orbit as well.
Yeah.
So there we are. Also, in December, the Zhuge rocket became the first rocket ever by anybody to put satellites into orbit, because it's methane powered. It's the first methane powered rocket to put satellites into orbit. It's beaten SpaceX, because SpaceX are obviously trying to do that with the Starship, and Blue Origins have got planned for methane as well, but China beat them to it. So China has become the first country to use a methane powered rocket to put satellites into orbit. So there we are. So that's my next story, and very, very great year for China in space.
Yeah, very much so.
Yeah.
But they're also talking about the Russians are sending a probe to Deimos and what's the other one? Not Amos, Deimos and Phobos, and they're doing a sample return from there. But China are also talking about sending a probe to Jupiter, and it'll be a sample return mission. And I bet they do it a lot sooner than NASA do, unfortunately.
Yeah.
But so, as I said, the space race is well and truly on now.
Yeah, it really is. And, we haven't talked about it because this is a look back at last year, but we know that the Chinese are probably going to beat America to the moon by the look of it.
But there's a question just popped in the chat. Do we think Blue Origin have any serious plans for anything?
Do they ever?
I'm zipping that.
Yes, I mean, I don't know whether you saw, there was an interview with Jeff Bezos just before Christmas, Chris, and in which he was actually being very complimentary about SpaceX and whatever.
But we know why that was, because he's just been sued by his shareholders for not using SpaceX.
You've got to be a bit careful. However, plans, according to him, are going ahead with the Vulcan. The Vulcan's coming, not the Vulcan, the New Shepard. New Glenn, that's what I'm trying to say. The New Glenn apparently is well advanced and running to schedule. So the only thing we know definitely about Blue Origin is that they plan to launch the New Glenn rocket, the maiden flight of the new rocket, sometime in the spring, I think. But we will see if anybody believes that. I certainly don't. But we will see. Let's hope we're pleasantly surprised. Daz, over to you for your next one.
Right. Okay, then. We're still here. The reason I'm still here is because we will be visiting Donald Johansson in April, the 20th of April, 2025.
Oh, I thought you were going to say 2024. Well, what is that?
No, because it's got to come back to Earth, and it's doing another slingshot.
That's right.
It visits Earth I think it's about 4 times altogether before it goes out to Jupiter, and then even then it comes back again and does another thing slot to visit to do the Greek camp. So so that's why I was still on that one. Right, okay then. So let's just proceed forward. Let me just get rid of right, so we can all see that. Right. My next one. I did say I didn't choose all the gems, but it's got to be mentioned, and that was the Starship test, Launch 1, and later on, in a little while, I'll be talking about Launch 2. Well, of course, 20th of April, 2023. We were all full of anticipation. We've been waiting for this for a very long time.
So long.
And it was, basically it was butterflies in the stomach time. And of course, it launched, but we all know what happened, unfortunately. And what it did, it launched, and some of the, unfortunately, the engines, at least 3 engines were out when it actually took off, possibly damaged by some things that happened during the actual fire up. But what we had is, here you got a few images of the actual launch. You can see things aren't right just by the exhaust and the flame coming from in the bottom right-hand corner. But that was this launch off. And of course, it actually launched. As it went on, more and more engines were failing. And it sustained damage. It appears to have sustained damage while it was on the launch pad when they fired up the engines. And of course, it started to lose more engines. Then it started to tumble, as you can see in these images. They did fire the self-destruct charges, but they didn't go off for quite a long time. But eventually, it did. It went through the fuel went through its own exhaust, and it did explode, destroying the actual machine. So it did fly. It was a proof of concept again. This is what it was all about: test, test, test. Get data, which is Mr. Musk's the way he does things. But this is what the result was. Those 33 Raptor engines had actually excavated a hole in the launch pad. And of course, this probably threw lots of debris back up into the engine bay. There was no water suppression system. There was no flame direction trench because they didn't think they needed them. It was a concrete pad, excuse me, which basically started to form cracks. And once you got cracks, then it basically disintegrated. So we ended up with this big hole at the base of the thing. But of course, not only did it do that, as you can see lots of debris flying around. This was I think it's about a mile or so away from the actual launch system. This is a remote camera site where remote cameras have been set up. And if you look at the car in the bottom image on the left-hand side, that is NASA Spaceflight's remote control car and camera control car, and it's just being pummeled with lots of debris, and it made quite a bit of a mess. What else happened? Because, as I said, debris was thrown over a very wide area, but also dust and fumes were thrown into the atmosphere, and they were carried quite a long way on by the air. But you can see things were thrown everywhere. And if you can remember, we were watching it, and you could actually see boulders falling into the sea, and it was quite spectacular, to be honest.
It was a good show.
I mean, it wasn't. It was a failure, but also it was a successful failure. If you know
what does Elon Musk always say before these launches? Excitement guaranteed.
Yeah, excitement guaranteed. So their response to this was within a month or so, they installed a full deluge system, which, of course, Elon said they never needed. They don't need a flame trench. They don't need anything. But all of a sudden, this appeared, and you can see it being tested here. And in previous shows, if you go back and look at our chats and all that, it uses a huge amount of water, which is all tankered in. They can't use seawater because it will basically trash anything that's metallic and rot anything. So it's all tap water. It's transported in, it's put into tanks, and then it's expelled, and it lasts only about 30 seconds at the most, probably not even that. But it's one of the most spectacular things you can actually watch. So that's what they did. They installed this. So next, come the end of the year, in November, 18th of November, we were at it again. This is an image taken from a drone. Really spectacular. You can see all the fumes and the vents coming off of the spaceship starship while it's sitting on the pad. You can also see how close these fuel tanks and on the right are, how close they actually are, and they still get pummeled now, even with the water. There's more dents every time they take off. So this is on this day. All the modifications have been made, because after the first attempt, there was a big outcry, and there had to be a wildlife assessment done, and this, that, and the other, and it was just sort of all dragging on. But to their merit, SpaceX just carried on with the job. They repaired everything, they installed the deluge system, and they did what they need to do for the next test. They did all their testing, so that as soon as they were offered given a license, they were able to go. So that was
Can
on the 18th.
I just interrupt for a second?
Yes, mate.
Because those fuel tanks are getting pebble dashed, basically, with the launches, they are being phased out, and those tanks you see laying on the ground, the horizontal ones, they're going to replace them. And even since that photo was taken, they've installed a few more of those. So the old vertical fuel tanks, which contain nitrogen, liquid oxygen, methane, and a couple for water as well, they're going to be decommissioned. So hopefully, with those horizontal tanks there, you can see on the ground, the risk of impacts will be a lot smaller. So there we are. Just what I tell you.
Yeah, they've made lots of modifications to the whole site.
Yeah.
So off we went. It was a perfect launch. Everybody's
heart. The weather was beautiful.
Yeah, I mean, of course, this was first thing in the morning. I have got some shots of the Starship and the booster on the launch mount while it's still dark, and you can see the stars and that behind. And of course, because it was in the morning, the sun was still rising. We had, you can see it here, this orange glow, and this played a very big part later on in some of the imagery. So yes, it launched. As you can see, beautiful day. And you can see it launched here, and all the engines are lit.
Yeah.
You can also see the fake diamonds in the exhaust. You get 4 or 5 of them all down this down the exhaust flumes. You see these fake, what they call fake diamonds. And it was a perfect textbook launch. Nothing could be faulted. And of course, you immediately noticed right from the word go that it left the launch pad a lot quicker, a lot smoother, and we knew things were on the right thing. This is just some of the images that were produced. As you can see on the bottom left there, you can see all the engines, all these little dots, ring of dots. That is all the engines are lit. And it was a fantastic sight to behold. So everything was running fine. We even had stage separation, which worked perfectly. And this is what I said about, because the sun was still rising, this sort of like rose feature, it almost looks like gravitational lensing, actually. It's the exhaust, the exhaust from the booster and the exhaust from the stage 2 interacting and being caught by the sun. So you get these lovely golden glows and all. And some of the images that they brought out were absolutely fantastic, especially with this part here. So everything's still going fine. The two parts, the booster and the Starship, separated. But for the booster, things started to go wrong straight away. It was supposed to fire its engines again. Some of them failed to start again. So again, we had this problem where everyone was unbalanced and all that. And eventually they had to terminate the actual booster. And this is the demise of the actual booster. I mean, all this debris went into the sea. But it done its job. And again, it's all data. Sorry. And of course, the Starship carried on towards space, but there was an issue, and eventually that had to detonated itself as well. That was a self-detonation. So these were 2 fantastic days. They were filled, everything was fine. We've been anticipating this for so long, and for have 2 launches, and they haven't stopped. Because just before Christmas, they've got their third. They're ready for the 3rd launch, literally.
Yes, they are.
Testing,
They are ready. Everything's ready.
Yeah, they even tested the Starship engines and the booster engines in the same day, within hours of each other. It was a fantastic thing. So
I know.
keep an eye on SpaceX, because I think this will be going off. Again, we've got another investigation going on, but I don't think it'll be as long as the last one was. But it's just a watch this space scenario before we get.
Well, the latest on that is that looks like the FAA may be ready with their report by the end of January. So we won't get to know why the vehicles exploded exactly until that report comes out. We can speculate, but lots of reasons. The favorite theory at the moment is that the new hot staging separation method, where the Starship fires its engines while the booster still has its engines fired, to give it that little bit of a kick, so it can even, in the future get into higher orbits for delivering satellites to geo orbits and lunar transfer orbits. That little bit of an extra kick makes all the difference. The idea is they think that possibly the firing of the Starship's engines hitting the top of the booster gave it too much of a kick, and it moved too fast, and fuel started to slosh around in the fuel lines, and that was it, which led to structural failure. Anyway, that was great, Daz. So
just a quick, there's another question appeared in the chat.
Yeah, sure.
It says Chris O'Riordan says, are there any missions to study Apophis
in
in 2029? Yes, there is. Osiris Rex is on its way there.
Oh, that's true.
It's when Osiris Rex dropped off its sample return. I think it's renamed now Apex.
Yes, Apex.
They were called Apex because it's going to Apophis. And it's going to rendezvous with Apophis, and I think it's just going to follow it into the sun. Of course, it can't do a sample return, although I did see in the news again that they were going to do a sample return from Apophis. No, they're not. Everything that did the sample return is back on Earth.
Yeah.
So get your facts right. It would be nice. Come on. But yeah, so there is a Apex is on its way, which was, as I said, was Osiris Rex, on its way to rendezvous with Apophis as it comes into the.
Sorry, Chris, I'd forgotten Osiris Rex is already on its way. There aren't any new missions planned to launch, but Osiris Rex is on its way.
Yeah.
Having dropped off the sample of asteroid Bennu on the Earth, which we'll talk about in a little while, actually. But let's move on. So my next story, straight on from that, definitely 2023 was the year of SpaceX, without any shadow of a doubt whatsoever. SpaceX, as well as the 2 Starship launches, have reached some major milestones this year. Let's just show you what I mean. First of all, the accomplishments of SpaceX this year: 98 launches, which compared with 61 in 2022. 91 Falcon 9 launches. They launched more Falcon 9s in 2023 than they had during the previous 10 years. Just imagine that. And 5 Falcon Heavy launches, and as we've just heard from Daz, 2 Starship and Falcon Super Heavy launches. Amazing from SpaceX. But it doesn't stop there. In terms of tons to orbit, SpaceX put 142 tons into orbit in 2023. The whole of the rest of the world put 157. So SpaceX virtually put as much into orbit as the rest of the world combined in 2023, which is absolutely amazing. Now, we said that Elon Musk sort of set a target of 100 launches for 2023. He said it would be nice. It wasn't anything that was a prerequisite or a goal they were actively working towards. He just said it would be nice if they could reach 100. Well, he has set a goal for next year, and the goal for next year is 144 launches. So this is what they plan to do next year. So an amazing year for SpaceX. I just want to mention one very small news story before we forget, that has nothing to do with that. And that is the company iSpace. And iSpace were trying to become the first private company to land on the moon this year with their Hakuto R lander. which unfortunately did get down to within striking distance, or certainly landing distance, of the moon's surface, and had basically ran out of fuel and crashed into the surface. But it was a fantastic effort from the Japanese company iSpace, and I'm sure they'll be back in the future with another attempt. But they could have become the first private company to land on the moon this year, and it's just dreadfully sad that they didn't quite make it, having gone so far. So there we are. So that's my next ones. Daz, what about you?
When you talk about iSpace, was that the one where they were using radar looking down onto the ground?
Yes.
What happened is that it was going along nicely, and then it met the edge of a crater. So first of all, it looked like the ground was coming up quick on the rim, but then it suddenly dropped away, and it confused the computers about how high it was, and that's why it ran out of fuel. Suddenly it thought it was too high. So it was too low, then all of a sudden it was too high. Confused it. So
that's bad luck. That's bad luck.
You just took some of the wind out of my sails.
Right.
I was only just going to mention it, but you went into a bit.
Okay.
Right. Okay then. So again, we're sticking with the Japanese theme. And first of all, I'm talking about the launch on the let me get this right, the 7th of September 2023. Why am I looking at my notes? It's on the screen. And it was the launch of the CRISM Space Telescope, which is an X-ray telescope, and the Smart Lunar Lander. And they were launched together. And now you're probably thinking, well, hang on, this telescope's got to be some size. How can they fit a lunar lander on there? The lunar lander is quite small. It really is. It's quite small. It's almost like a coffee table size at the most, at the best. But this is full of new technology, literally is. And of course, it was launched on September, and it actually went in. The reason I'm talking about it now, it went into lunar orbit on the 25th of December, so on Christmas Day. Sorry, I'm just so it went into orbit because it did it when the long way round. Again, it was using gravitational more gravity to actually get it to the moon. It went way past the moon, and it slowly made its way back. It's now in orbit, and it will slowly work its way down towards the surface, and it's due to actually land on the 19th of January. So hopefully we'll be around to cover that.
We'll do our best to cover that.
Yeah, it's a funny. I think it's a bit of a funny time. I think we're talking about it, Andy. It was
early morning.
It says 12 o'clock a.m. Japanese time. Well, I think they're 9 hours ahead of us. So we'll have to come, but so we'll have to come bring it back here to whatever it is there. So we'll talk about it.
We'll sort it out.
Yeah, we'll sort it out later. So hopefully, but the amazing thing is this is all proof of concept stuff. The actual landing module that will be used is called SLIM, but it's also nicknamed the Moon Sniper. It's called SLIM because it's the smart lander for investigating the moon. It does what it says on the can.
Yeah.
And they're calling it the Moon Sniper. And the reason for this is the Japanese have had a orbiter photographing the whole surface of the moon, and they've inputted all the images into the system, and it's going to use like face recognition technology to, as it comes down towards the landing, it's going to use face recognition to recognize points on the moon, the craters, high spots, mountains, boulders, and rocks like that. And they hope to land within 100 meters of a specific target on the moon. Their thinking is that with the technology we got now, and because we're going to be landing on the south of the moon, and of course we all know the south is pretty rugged. The South Pole is a rugged place. It's full of craters, full of holes, that people need more precision. So this is why they've called it Sniper. It's using this technology, and they hope to land within 100 meters of a specific target. We have spoke about this before in the past thing.
Yeah.
The whole thing, as I said, was launched in September. And it will start its, as I said, it went into orbit on the 25th, and it will start its descent on the 19th of January. That's for us, but for them, it'll be the 20th of January, as I said, their thing.
Sure.
The lander is equipped with a special little probe. Now, this is something else, again, another proof of concept, that's been designed by, it's a little rover, and it's been designed by a toy company. And it's
not Hot Wheels.
No, Transformer. So you're going to get an Optimus Prime land on the moon like they do in the.
Yeah.
But it's only a small thing, but it can actually change its shape to navigate around objects. So it's going to go off, do its little bits and bobs, but it can actually, as I said, it will change its shape to adapt to the circumstances that it's actually finding. So this is all, and it's going to be sampling things like looking for lunar permafrost. And things like that, and basically uncovering the mystery of water on the moon to see what they can actually do. As you said, this is their third attempt. There have been 2 failed missions by the Japanese, one public and one private. Last year, the country unsuccessfully sent a lunar probe named Omotenashi as part of the United States Artemis 1 mission, which failed, unfortunately. Not the Artemis 1 mission, we know the lander. And as Andy said, in April, the Japanese iSpace tried in vain to become the first private company to land on the moon. So this is what, again, I thought this is a fantastic little. If you read about the what's on there, the proof of concept things again. And as I said, to launch again with the space telescope, again, the Japanese are up and coming, and they are well entrenched in
Absolutely.
the.
Can I just say a couple of words about the space telescope itself?
Yeah, carry on, mate.
The CRISM space telescope, being an X-ray telescope, it's really filling a gap that's going to happen in X-ray astronomy over the next few years, because both the Chandra X-ray telescope and the XMM Newton X-ray telescope are both getting on in years and are not expected to last that much longer. So it's great that we now have another X-ray space telescope in orbit, ready for when that happens. We need more, of course, and because X-ray astronomy is vitally important to understanding objects in the universe. So anyway, well done to Japan for
also, didn't India launch a X-ray?
Yes, they did. In fact, 2
days ago, was
it? Yes, it was yesterday.
Was it yesterday?
I get confused.
I know it's 4 o'clock in the morning because I stayed up.
Yes, it was 4 o'clock in the morning yesterday. India, I should have mentioned this earlier, really, in connection with India. They've launched an X-ray satellite called XPOSSat, and another successful launch for India to start the new year.
And I know the Europeans have got an X-ray telescope that they're launching towards the end of this decade, called Athena. I think it's called Athena.
Athena, that's right. And Athena's going to work hand in hand with the LISA gravitational wave detector. So perhaps we can do a feature about that at some point. That's a really interesting story too. Okay, let's move on. My next one, we've talked about it a lot.
Hang on, mate. Let me get rid of this.
Oh,
I didn't go through my slides.
Sorry.
There's the actual lander, and you can see it's actually releasing Slim to actually do its landing thing.
Yeah.
So I'll just quickly flip through them, and that's the lander on the moon. So there you go. Yeah, sorry about that. Sorry, my bad.
That's all right. So my next one, and we've talked about it quite a lot already, but we may as well have a look at it. OSIRIS-REx, the asteroid sample return mission. And this was a very successful mission. And the mission was conceived to return a sample from an asteroid. The asteroid in question being asteroid Bennu, which not much was known about it before launch, but it's turned out to be more of a rubble pile than a solid body. And the ambition was to grab some of it and return it to the Earth for analysis. Don't forget, these asteroids are really leftover material from the birth of the solar system. So they are extremely primordial material, and therefore incredibly important to study them. So this is the moment when the sample was taken, with the sample arm going towards the surface, blasting nitrogen air into the surface, or nitrogen into the surface, to throw up material which was then collected. Now, this actually worked a lot better than expected, because they collected, in essence, too much material. And when they came to shut the container that it contained, they couldn't get it shut because there was so much material in it. This, eventually 2 years later, was the capsule laying on the floor of the Utah desert after it had returned on a parachute through the atmosphere and was successfully retrieved. Amazing look inside the collector thing itself. Well, this is, as you can see, the lid of the collector is shown there at the bottom, secured by 6 bolts. And even outside the collector, there's a lot of material, which thrilled scientists because they weren't sure how much they'd collected. It turns out they collected about 250 grams of material from the asteroid in total. And here's a close look at that material. 5 out of those 6 bolts, incidentally, came out without any problem. But as anybody who works with nuts and bolts will know, there's always one. And they had to design a special tool to remove the last bolt, which took a while. But they have got it open now to get at the bulk of the material. This material that you're looking at is extremely abundant in, guess what, water. So this was a bit of a surprise that there was so much water in this asteroid in the depths of space. But that material is extremely water abundant. So there we are. So that's my next one, the OSIRIS-REx project to return primordial material. And you are looking at material from the very birth of the solar system, 4.6 billion years old. So this was an incredibly successful mission. That stuff is going to be studied around the world for years. The British sample, has already arrived at the Natural History Museum for analysis, and I think there will be some major findings to come out of that.
Because with what they could see, they actually put it under ultraviolet light, and there are things in there that are fluorescing. So
yes, that's
lots
right.
of different minerals and things like that.
Yeah, I mean, it's going to be a treasure trove of information about the birth of the solar system.
Yeah,
really exciting mission.
And also, they sent a sample to the museum in London, didn't they?
Yes, that's right. That's right. So and they're absolutely thrilled because they are real experts in analysing. Like the carbonaceous chondrite that fell in Gloucestershire ended up there for analysis. The Hinchcombe meteorite.
Hinchcombe, that's right.
Yeah. So there we are. Okay, Daz, over to you then.
Right. Okay, then. I think we're going to have to move this on a bit. We're sort of like...
Yeah, I think we are.
My next one, and actually, this was right at the very end, and we've only just seen the pictures today, myself and Andy. But this is Juno's flyby of the Jovian moon Io, and that's happened on the 30th of December. It's done several flybys so far. This is the closest, and it will be doing exactly the same again in February. This will be the lowest it's going to actually get to the surface. Of course, we know Io is the closest moon to Jupiter. It's a tortured planet. It's probably what we all think of as hell on Earth. It's absolutely covered in volcanoes. There's been some imaging of using infrared, and you can actually see. You can see the volcanoes here. Look, you can see you can see the shadows being cast by the sun. And they're
we can only see the artist's impression at the moment, Dad.
Oh, sorry.
We can see them, but they're painted.
Too excited. This is an older image, and this is one I've had for a long time.
Image,
and it's as you can see, so I think it was Galileo took this one.
Yes, it was.
And you can see all the yellow is thought to be sulfur, and there's obviously you can see a red ring around this volcano down sort of like just bottom right. and that was obviously looks like a very recent eruption. And of course, because Io is so close to the Jupiter, that they think it's basically it's tidal locking. It's solid. There's no water on Io, which is understandable, but it's being pulled and twisted by the gravitation. It's the same as the moon has an effect on Earth, as well as doing tides. It actually would do a land heave as well. And this is to the extreme. And of course, it's torture and twisting, keeping the center of Io molten, and of course, then it cracks open, and then you get all these volcanoes. One of the most volcanic object we've got in the solar system. It's absolutely beautiful we've got, and I think it's fantastic. It's fascinating. So this is another image that was taken. I think this one was taken on the 10th of October last year. And again, you can see what I was talking about. Probably do with a bit of a zoom in on my image. But you can see the mountains and the volcanoes there. You can see the shadows being cast. But the image is absolutely fantastic. And of course, what we've got to remember is Jupiter, as Juno, this is its second mission. It's its second mission. It's been extended because for a long time it was orbiting and taking images of Jupiter, and we can remember those fantastic images of the clouds swirling around, and we still get them now because it does gravitational swings around Jupiter. This is why it'll be coming back here and doing exactly the same. Now, what did I say? The flyby of Juno will bring Juno 930 miles or 1,500 kilometers off the surface of Io. So that's the closest it's going to be. And it will do exactly the same. Do exactly the same in February. Eventually, unfortunately, because Juno's been in operation for so long, unfortunately, there's degradation on the cameras. I mean, they're being pummeled by radiation, space radiation all the time. So there is some degradation, and I think you can see it in this next image. It's not come up so well. It probably is if you're on a bigger screen. I'm looking at it in a small panel. But you can see there's lines going horizontally across.
Yeah.
And that's degradation of the...
That's radiation damage to the camera.
Yeah, that's radiation. So, but also, the reason I put this image up, you can see, again, the top half, you can see the surface. But just below on the sort of like the 9 o'clock region, you can see a little plume in the dark side. And that is an actual volcano erupting. There's a little red arrow pointing to it if you're having trouble finding it. But you've also got a bit of Jupiter shine there. Look, you can see almost the other side of it. So, but the images we're getting back of it are absolutely fantastic. So again, this has all happened, literally in the last couple of days. The images have come through. Unfortunately, I haven't been able to put them up. That's another one. But I think Andy's got them, and hopefully we might be able to see them. But we had a look at them earlier on, and they're absolutely stunning. Absolutely stunning. So this is, for me, this is another major event. This is unexpected. We weren't expecting this because, as I said, Juno was finished. It's about 3 years ago. I think it's 3 years now since it finished its original task, and then they reassigned it to visit some of the actual Jupiter's moons, which are absolutely fantastic.
Yeah.
So there you go. Thank you.
Yeah. Okay, thanks, Daz. Well, we can't let this year go by, of course, without mentioning the amazing work that's being done by the James Webb Space Telescope. 2023 was definitely the year of the JWST. It really came into its own as an instrument and has delivered images across a wide variety of targets across the universe. And I just want to go through some of my favorite images from this year. Not all of them, obviously. We'd be here forever if we showed you all of the images from the JWST from 2023. But let's have a look at some of them anyway. So the first one, this beautiful image of the core of the galaxy M51. these galaxies, which look very different in the infrared, of course, they look distinctly spidery and full of webs and intricate structures that we don't see in visible light. So this was an image of the of M51. This is a very recent. This was released towards the end of December. A new image of Uranus. Notice how bright the rings are in the infrared in this image, and we've got some white dots on the surface, which are clouds of Uranus. We also had this lovely image of a target which you astronomers are all familiar with, I'm sure, the Ring Nebula, famous Ring Nebula M57. Again, looking very different in the infrared to what it does in invisible light. Webb has also been looking at some star-forming regions in the universe, and a couple of images here. This beautiful star-forming region where young stars are being born. This one as well, which I think is one of my absolute favourites from any year from the Webb, either from 2023 or the year before. Amazing image of a star-forming region. Webb has also discovered the earliest black hole so far found in the universe, and this was a supermassive black hole that existed a mere 470 million years after the Big Bang. So this has opened up the question yet again as to how these supermassive black holes formed so early in the history of the universe. And talking of observing supermassive black holes, here's a graphic which shows you the improvement in doing this that the Webb has delivered. Now, along the bottom, we've got the age of the universe, and going up the side, we've got the black hole masses. As you can see, the black hole, or the location of the black hole I've just shown you, that's a supermassive black hole called Sears 1019. It is the earliest known at 470 million years after the Big Bang, and has a mass of just short of 1 million solar masses, 900,000 solar masses. This is actually a bit of a lightweight because others from roughly the same period are actually quite a bit more substantial than that. So that's an interesting question as to why this black hole is actually so light, even though obviously 900,000 solar masses is a huge amount of mass. But this is pushing back to 470 million years after the Big Bang. On the right-hand side, you've got two others from around 1 billion years after the Big Bang, Sears 746 and 2782. But if you look in the rest of the graph, this is what has been delivered by previous telescopes like the Hubble. And that area there, that coloured area, are detections by other telescopes. So as you can see, the Webb is pushing far further back in time than any telescope's been able to ever before, and stands to make some momentous discoveries about the whole business of supermassive black hole formation, and of course commensurate with that galaxy formation. This is a lovely image of a complete Einstein ring, which I quite liked. We do see Einstein rings quite often, but this is one in incredible detail from the Webb. And we move on. The famous Fomalhaut young star with a planetary disk around it. The Webb has actually got a beautiful image of this. If you look at the right-hand side, you'll see a label, a great dust cloud. There's a sort of a knot in one of the rings of dust surrounding this young star, and this could well be a planet being formed. Mind you, we've been caught out before with Fomalhaut because about, how long ago, 6-7 years ago, they thought they'd discovered an actual exoplanet, if you remember that, and it turned out to be a knot of gas and not an exoplanet at all. But this looks like it could be a gas giant in the process of forming in that ring of dusty material around the star. An amazing image. Then we go to a star called PDS 70. An amazing discovery about this star was that its inner disk of material surrounding a young star has got a huge amount of water in it. And if you look at the spectrograph from the Webb, the water model is in white, what that star would look like with that amount of water, and the Webb data just more or less completely matches it. So this is a young star that has a truly astonishing amount of water in its protoplanetary disk surrounding the star. And, the question about the Earth has always been, where did the Earth get its water? Well, here's an example of a star where that water was born with the star. So this is a really, really interesting study in how planets perhaps can end up with the water that they do, especially planets like the Earth. Moving on, exoplanet K218b, the discovery of methane for the first time in the atmosphere of an exoplanet. And it's a very strong methane and CO2 signature there, but also dimethyl sulfide is there. And this was an interesting find as well. The Webb has been looking closer to home. This is an emission spectrum from the water torus surrounding Saturn's moon Enceladus, which we've talked about often on Space Oddities. But if you look at the image on the left, you can see the plume of water very, very clearly emanating from that little moon of Saturn that is so mysterious. So talking about this little moon just before Christmas, they announced that they found an amazing variety of organic material in that water and a really powerful energy source powering those geysers, if you want to call them that shoot out of Enceladus and whose material forms the E-ring around Saturn. So that was interesting as well. Next one, we've been waiting for the results from the TRAPPIST system, the system of 5 exoplanets that everybody's been so hopeful could be Earth-like and contain life. Well, this is the spectrum from TRAPPIST-1c as taken by the Webb. And really, if you look at the vertical white line representing the error bars and the red diamond in the middle, was the actual measurement. It's sort of falling between a thin carbon dioxide atmosphere with no clouds or a bare rocky surface. Basically, this planet is not going to support life as we know it, unfortunately, which was a big disappointment because a lot of people have been hoping that this system, which has 5 Earth-sized planets, would at least one of them would be suitable for life. TRAPPIST-1b, another one in the system. There were 2 models basically for this one. Either there was an atmosphere distributing heat evenly around the planet, or the other model had no atmosphere, no redistribution of heat. But if you look at the actual measurement, TRAPPIST-1b turned out to be actually hotter than the Earth at over 500 degrees Kelvin. And that is probably going to be too hot to support life. It's too close to its star, and its atmosphere is just too hot to support life. So unfortunately, it's looking a bit doubtful for the TRAPPIST system whether any of those planets could support life around this very young red dwarf star, which gives off a lot of radiation, which again doesn't help things. And that's it for my one here.
Yeah, because you mentioned when we started the show, you mentioned cosmology.
Yeah.
They're beginning to wonder as oh, sorry, am I still showing? Sorry.
Yeah.
They have wondered whether the James Webb has broken cosmology because of so many discoveries.
Well, I think we should set the record straight about this. There's been so much nonsense talked about this in the media and on YouTube and everywhere. There's been so much clickbait and misinformation.
Yeah.
Just want to make it quite clear, nothing that we've seen in the Webb data breaks cosmology in any way at all.
That's I mean, you that's what I was just going to get to. But basically, it's opened up old wounds. Because, like I said, you were talking about huge black holes. How did they form so early? We weren't expecting that. Huge galaxies as well. How did they gather so much mass together? We weren't expecting that. So, and there's some talk about, that means that the only way we can fit the data is that the universe, the universe must be older, twice as old as what we said it was. But what it is people getting hold of the data and they're looking at it in different ways. And this is what it's all about. We've got to take the data and look at it, and people will come up with different conclusions. And somewhere in between, we will find the right answer. But a lot of it is a lot of this stuff has been rushed. They want to be the first to get out. Some mistakes are being made, but most of them is just sort of like misinterpretation of the data.
Well, and sadly as well, in a lot of cases, it's willful misinterpretation by the media.
I agree with that.
Who wants a scandalous story. it's the old story. It is this whole business of misinformation is getting worse, especially on YouTube and other social media.
Exactly, because on YouTube, I see the static state has raised its head again, and there's been even people on there declaring that the static state is the true.
I know.
This is where the universe hasn't changed, but you can't deny the expansion. So as I said, we're getting into
anyway. Time's getting on. So, do you want to move on with your next one?
Well, if you want, I mean, I noticed we're on over 90 minutes. Do you want to hold the next ones till next week?
Yeah, we can hold these over till next week.
Because my next one's a bit more involved.
Yeah, I've only got one more left.
I've got two more.
Okay. We'll hold these over to next week as time's getting on.
But one thing I would like to mention before we go, because also next week we'll be looking at the year ahead, what we can expect in space flights, missions, and things like that, and what's going to happen. But before we actually come back on air, remember on the 8th of January, we're expecting the Vulcan Centaur to make its maiden flight. And of course, that's also carrying the Peregrine lander, moon lander. So,
which is also carrying Britain's first moon rover, we think.
Little city. So I just thought I'd better put that in there. Hopefully, we'll be covering it. It's I think it's about 18 minutes past 7. The launch is expected
in the morning or the evening.
In the morning,
right?
It's a Monday morning, unfortunately, about 18 minutes past 7. That'll be 8 o'clock.
We'll be there.
Yeah. So we'll sort something out and see if we can.
Put that in your diaries. Next Monday morning, the 8th of January. We will be covering the maiden launch of this incredibly important rocket for ULA, the Vulcan Centaur, live here on Space Oddities. Keep your eye on the Facebook page, the Facebook group where we announce changes and things like that. So at the moment, we're going to say we're definitely going to do it. We will keep you informed of any changes. Now, Michael, I think you had something that you...
yes, I do.
Yes. So there we are.
Yeah, I just want to let everybody know that the latest edition of Capcom magazine, Spaceflight and Astronomy magazine, is available, published 6 times a year, containing original articles from published authors. It's just £14 per year for printed copies to be sent to a UK address, or £10 a year for PDF electronic copies to be sent to any email address. Full details are at gospacewatch.earth. This edition covers a couple of good history items. First of all, it's the 30 years since the first Hubble servicing mission, which fitted the CoStar lenses to correct Hubble's vision. And also 50 years since the third and final crew of the Skylab space station mission in December 1973. So a couple of big history items there. I'd also like to go on to the next slide, Andy.
Well, you can do that in a minute. Yep, there you are.
Okay. Next week on the 10th of January, the Carolean Astronomy Society in Kidderminster has a meeting at 7:30 next Wednesday, the 10th, at King Charles School in Kidderminster. Our speaker is Dr. René Breton from the Jodrell Bank Centre for Astrophysics, talking about the Space Orchestra, about how scientists take data on star vibrations and turn them into sounds. Details of this will be on the Carolean website tomorrow, and also on the Carolean Facebook group. So that's what I've got to say about that tonight. Thank you.
Thank you, Michael.
Sonification of the universe is a fascinating subject.
Yeah, absolutely. It is. Yeah, it really is. So there we are. Okay, right, we're going to draw things to a close here this evening. We'd like to thank you all very much for being with us, and obviously we'd like to wish you a fantastic week and a fantastic 2024 while we're on the subject. Thank you for those of you who have been here, and thank you for those of us who can see have bought us coffees, which is very, very kind of you. And it will keep us in that liquid gold caffeine to which we are accustomed.
Yeah.
And there we are. So we will be back, firstly, next Monday, if all goes well, unless the launch is postponed, on Monday morning for the launch of the ULA Vulcan Center, its maiden launch, an incredibly important rocket for the future of ULA. So keep your eyes on the Facebook group in case we change that. And we will be back as normal next Tuesday at 8 o'clock UK time, 3 p.m. EST. So from all of us here at Space Oddities, thank you so much for being here. Have a fantastic week. Keep looking up. Let's hope the weather improves now we're into 2024. Get rid of all that awful wind and rain and get some observing done. So I have to admit, since I've been back here in Spain, I spent Christmas in Pembrokeshire. But since I've been back in Spain, we've had clear nights. So I'm hoping that perhaps I can get out a little bit later tonight. All right, then. From all of us at Space Oddities, thank you so much again for supporting us in 2023. And we hope you continue to do so in 2024. And from all of us here, we wish you a very good evening.
Bye all. Happy New